Good morning, dear students.
Good morning, ma'am.
Very good morning. We are discussing about architecture of commercial devices. So, as till now we have discussed about two different HDL, that is a hardware description language, VHDL and Verilog. And then we have seen how to write program using these two languages. At the same time, we have seen how to simulate these programs using Xilinx ISA. Okay, so that also we have seen in earlier sessions. So now we are actually going to discuss about commercial devices uh, that are available in the market. So how we can program these devices, and then we can get a particular function that to be verified by using these devices. Okay. So we are discussing about architecture of different commercially available devices. So as we discussed in the earlier lecture, that there are a lot of many devices that are available in the market, and because of that designer gets confused which one to be selected depending on the required specifications, and what are the advantages and disadvantages of that devices. So here in this unit we are going to discuss about a few commercially available devices, that is a CPLDs and FPGAs that are available in the market, so which are mostly used in the uh, for developing this VLSI IC. Okay, so here before discuss going for actually CPLDs and FPGAs, before that we are going to discuss about basics of programmable logic devices. Okay, so what is mean by programmable logic devices, and then what are the different types of these devices, and then we will go for these different commercially available devices. So as in the earlier session, we have discussed about what we are going to learn in this unit, what are the different outcomes that from this unit, so that we have discussed. And now in this session, let us discuss about what is mean by programmable logic device. Okay. So I'll share my screen now. Am I audible? My voice is clear?
Yes, ma'am. Yes, ma'am.
Okay. So we are discussing about programmable logic devices. Now, as the programmable, the word itself means that these logic devices that we can configure. Okay, so or we can program it depending on our application or user's application. He can configure that device. Okay, so the programmable logic devices, in short, it is called as a PLDs. Is an IC that contains large number of gates. Okay, or it contains large number of flip-flop also, and that can be configured or programmed by the user. So that is the definition of this programmable logic devices. So these PLDs that are typically built with the array and gates, okay, of AND gates. Okay, so it is a full array of AND gates and an array of OR gates. So you can see in this diagram that this programmable logic devices, it is an array. First, it is an array of AND gate, and then it is followed by output of that AND gate array that is given to the as an input to OR gate array, and then we get the output. Okay. So, in short, we can say that programmable logic devices that performs SOP operation, that is a sum of product form. Okay, functions that can be programmed using this programmable logic devices. Now, as we know that AND gate that gives us the product of the inputs, and then OR gate that gives it a sum of the inputs. Okay, so that means overall this PLDs that gives us SOP form functions. Okay, so you can see that this is the generalized PLD. Okay, so here generic PLD structure that you can see in this diagram. So here we have uh, first input device input, that suppose we are having n number of inputs to this device. Okay, so uh, if there are n number of inputs, that means that it may be in the form of zero logic or one logic. Okay, so it may be use that input can be connected to the AND array through buffer or inverter. Okay, so that means this is the array for inputs. Okay, so it could be inverter. Then we will get what, suppose A is the input at this point. So if it is connected through inverter, then here it will be A bar input to the AND array. And if it is uh, connected through buffer, then it will be A only. Okay, so that means here for each of the input we can have two logic levels, that is a 0 and 1. Now array, that means number of AND gates that are connected in the circuitry. Okay, so here AND array connections that will be present. Okay, so that is given. And as we have to n number of inputs, that means we will get 2 raised to n number of outputs. Okay, so here we will get 2 raised to n number of outputs. So 2 raised to n number of AND gates will be required to get this outputs. Okay, so here we can say, in other words, we can say that here we have decoder like structure. Okay, so that will be present. And here there is a OR gate. So all the outputs of AND gate that are connected to the OR array connections, and then from that we will get a device output. So here it is a AND array, and here it is a OR array, and here we have the different connections for this AND gates. Okay, now user can program these connections. Okay, and depending on the connections we will get particular output. So depending on user specifications and requirements, we will get particular output for these circuitry. Okay, so now if this, now in some cases this AND array may be fixed, and OR array that may be programmable, or AND array may be programmable and OR array may be fixed, or both are programmable. That means we can change the connection in both these arrays. So depending on that, there are different types of these PLDs. Okay, so we are going to discuss about these types here. But here now you can see that as we can implement SOP functions using these PLDs. Okay, so depending on, as I said, whether AND array is programmable or OR array is programmable, or if both are programmable, there are different types of PLDs. Okay, so there is a one type, that is a programmable read-only memory, then programmable logic array, that is a PLA, and programmable array logic, that is a PAL. All these three types that are types of actually simple programmable logic devices, that is called as a SPLD. Okay, so these three types that are of the SPLDs. And then other than this, we have another type of PLD, that is a complex programmable logic device, that is we call as a CPLD. In short, this word that is known to all of you, that is a CPLD, which is a complex programmable logic devices. And in complex programmable logic devices, we have number of PLDs. Okay, and that is why we call this as a complex, because there is a complex logic functions it can perform, and that is why it is called as a complex programmable logic device, or CPLD. And another type of PLD, that is a filled programmable gate array, or FPGA. Now, uh, as you have all learned about VLSI design, that means this word you have heard earlier, that is a FPGA, field programmable gate array. Okay, so let us first have the knowledge about all these three types of PLDs, and then we will go for the CPLDs and FPGA. Actually, our main interest is CPLDs and FPGA, because we are going to discuss about commercially available CPLDs and FPGAs. But as when we are going to learn about these PROM, then PLA and PAL, you will get basic idea about what is mean by PLDs, how they are programmed, and after that we will go for this CPLDs and FPGA, and then we will learn about what are the different types of commercially available devices. Okay, so we are going to learn about some devices that are available in the market. So as this PLD logic capacity, then if you are going for SPLD, so they will have up near about 200 gates in that single IC. Okay, if you are going for CPLD, that is a complex programmable logic devices, then there may be near about 250,000 logic gates in a one IC. Okay, if you are considering about Altera Flex, then nearly about 250,000 logic gates are available in that CPLD. Then if you are going for Xilinx XC9500, that is also having more number of gates, okay, in a logic gates in a single IC. Then FPGA, that is a more complex than that of a CPLD. So if you are considering Xilinx Vertex E, then in a single IC there are 3 million logic gates that are available. So that means that much complex circuitry which is having this many logic gates that can be uh, performed or that can be built using this Xilinx Vertex E. Okay. Also, Xilinx Spartan that has 10,000 logic gates, and Altera that is also having a same number of logic gates in that IC. Okay. So this is the logic capacity of these all programmable logic devices. Now, if we are comparing these PLDs, okay. So if we are considering just right now a simple programmable logic devices, then the first type, that is a PROM. So in a PROM, that means programmable read-only memory. So in a this type of PLD, and array connection that is fixed at the factory. Okay, so that means we cannot change or user cannot change these connections, but customer or user can program or array connections. Okay, so that means whatever changes that he want to do, that should be done at a or array connection. If you are considering about PLA, then it is programmable at a and array connection, and it is um, also programmable at or array connection. So that means both and as well as or that are programmable. And if we are considering PAL, that is a programmable array logic, then it is programmable at and array connection, but it is fixed at or array connections. Okay, so this is the difference between all these PROM, PLA, and PAL. Okay, now here when we are calling as a programmable, that means programmable at a hardware level. Okay, we are not considering this at a software level. Remember that this programmable, that means at a hardware level. So whatever is the hardware that we can change, and that could be done using these programmable logic devices. So now let us see the structure of these programmable logic devices. Okay, so as all of these programmable logic devices that will have and or structure. Okay, only they will differ in which it is programmable. So that means if we are considering about PROM, then as I earlier said, it is fixed at AND array. So it could be as it is a fixed at AND array, so we can call it as a decoder. So this first part of this programmable read-only memory, that is a PROM, that is a fixed AND array, and it is a decoder section. Okay, and then there is a programmable connection between the output of this AND array and program or array. Okay, so that means or array is a programmable in a PROM. Okay, that is a programmable read only memory, and then we will get the output. So here only we can program. So depending on our function, we can change the output or we can change the functions at or array. Okay, Then in a programmable array logic, that is a part, we have programmable connections at AND array. So here this AND array is a programmable. So the product terms that are programmable, and here it is a fixed OR array. Okay, so the similar whatever table we have seen earlier, the same is in terms of diagram. So then in a programmable logic array, both AND array as well as OR array that are programmable. Okay, so that means whatever connections that we have, that could be changed, or that could be configured in a different ways. So this is about all the SPLDs, that is a programmable read-only memory, then programmable array logic, and programmable logic array, that is a PLA. Now, actually, we are programming these logic devices, that means these inputs. That means what we are actually doing, we are programming it by blowing fuses. Okay, so there are certain fuses at between the input and the input at the logic gate. So here if you can see that this is a AND gate. Okay, so there are certain fuses between this input, okay, a input, then here as this is a 4 input AND gate. So there are 4 inputs, that is A, B, C and D. So you can see that there is a fuse in between this input and a input of this AND gate, actual input of this AND gate. So before programming this, this will have the structure like this. Okay, so here you can see that all the fuses that are connected together. But after programming, you can keep only whatever inputs that you want to be present in the that circuitry, or that function. Okay, so depending on the Boolean expression, which inputs you want to be given to that gate, so only that you can keep it, and other fuses that you can blow off, and therefore that connection will get loose. Okay, so इथे तुम्ही बघू शकाल की इथे तुमच्या ज्या सगळ्या फ्युजेस आहेत त्या इंटॅक्ट आहेत. ओके, आणि जेव्हा तुम्ही प्रोग्रामिंग करता, म्हणजे मला जर फक्त या गेटसाठी आउटपुट मला बी सी हवं असेल, तर मी काय करेन की या जे ए आणि डी चे फ्युजेस आहेत ते ब्लो ऑफ करेन. ओके, सो दॅट देर विल नॉट बी एनी कनेक्शन फ्रॉम ए अँड डी, and only B and C will be available at the input of this AND gate, and therefore I can get output that is B, C. Okay, so in this way, this programmable logic devices, these are programmed. Okay, so there are in this way the connections are done, and then we get the proper functioning of this circuit. Okay, so as I earlier discussed again, this PROM structure which has a fixed AND array and programmable OR array. So if there are n number of inputs, for this fixed AND array, we will get 2 raised to n number of outputs. That means this fixed array AND array, that is a decoder in this circuitry. Okay, so that is then nothing but decoder, because decoder that gives us a output which is nothing but if n number of inputs are there, 2 raised to n number of outputs we will get for that circuitry. So AND structure or AND array for PROM, that is a fixed AND array, and then we have a programmable OR array. Okay, so this is the next structure, that is a programmable OR array that will be available, and then we will get m number of outputs. So as we can change the connections here which are going to this OR array, so depending on that we will get a m number of outputs as a output to this circuit or this PLD. So let us have one example of this PROM. Okay, suppose I want to implement a Boolean function which is having a 3 inputs x, y and z. Okay, so my first function, that is a x, y, z, that is nothing but a summation of minterms 5, 6 and 7. Okay, and another function, that is a b, which is summation of minterms 3, 5, 6 and 7. Okay. Now what is mean by mean terms? What is mean by mean terms? All of you have learned this in digital techniques.
मॅम मिन टर्म म्हणजे जे नंबर्स दिलेत ते इक्वल टू 1.
So so the product terms, okay, whenever we are having the input, so that will be for this terms output will be equal to 1. Okay. So depending on that, now so we are considering here as a 3 input. So we have AND array logic for this PROM, that is a 3s to 8 decoder. Okay. So here for M5, M6 and M7, these will be 1 for a first equation, and 3, 5, 6, 7, these will be 1 for the second equation. Okay. So here all these outputs, okay, from this decoder, that fuses at this, that will keep intact, and other fuses that will be blown off. Okay. So here there will be connections to this OR gate from M5, M6 and M7 only. Okay. So here you can see that where there is a connection, that is shown by a cross. Okay. इथे जिथे क्रॉस आहे तिथे प्रत्येक ठिकाणी कनेक्शन आहे, म्हणजे M5, M6 आणि M7 ला कनेक्शन असणार आहे OR गेटला. इथे काय होणार आहे, ह्या सगळ्या प्रोडक्ट टर्म्स ज्या असणार आहेत, म्हणजे आता ऍक्च्युली मेन टर्म्स नथिंग बट प्रोडक्ट टर्म्स of this x, y and z. Okay. So this will be available as an input to this OR gate, and then depending on that we will get the output A. Okay. And for this B output to be available, we need to have the connection at M3, then M5, M6 and M7. Okay. And then from that we will get output B. Okay. So similarly we can do programming for another फंक्शन्स. ओके. म्हणजे इथे आपण काय करतो की हे जे काही कनेक्शन्स आहेत त्याच्याप्रमाणे आपण कनेक्शन्स ठेवणार आहे, बाकीचे जे फ्युजेस आहेत त्या ब्लो ऑफ करू, त्यामुळे तिथे कनेक्शन्स नसणार आहेत. म्हणजे एवढेच कनेक्शन फक्त आपण प्रोग्रामिंग थ्रू करणार आहे की ज्याच्यामुळे आपल्याला आउटपुट मिळेल. आणि मग हे जे काही आउटपुट असणार आहे हे काय आहे, सम ऑफ प्रोडक्ट टर्म्स, कारण ह्या ज्या प्रोडक्ट टर्म्स आहेत त्याचा सम असणार आहे. म्हणजेच आपण ऍक्च्युली कुठलंही पीएलडी जर बघितलं तर आपण त्याच्यामध्ये काय करू शकतो की ज्या तुमच्या प्रोडक्ट टर्म्स आहेत त्यांचे सम करतोय. ओके. दॅट मीन्स वी आर ऍक्च्युली इम्प्लिमेंटिंग एसओपी functions when we are using a PLD. So as we again you must be knowing that there are two different types of functions, that is the SOP, sum of product, or product of sum, that is a POS. Okay. So but we usually use SOP function, so we are implementing this using this PLD. Okay. So all of you got this. काय करतो आपण प्रॉम मध्ये, हे कनेक्शन्स आहेत जे इनपुटचा अँड अरे तो तर फिक्स आहे, फक्त आपण इथं चेंज करू शकतो की प्रोग्रामिंग थ्रू, आणि इथले कनेक्शन्स आहेत हे ज्याप्रमाणे आपलं बुलियन एक्सप्रेशनची रिक्वायरमेंट आहे त्याप्रमाणे तेवढेच कनेक्शन्स इंटॅक्ट ठेवू आणि बाकीचे अदर आहेत ते ब्लो ऑफ करू किंवा त्याच्यामध्ये काही कनेक्शन्स असणार आहेत. म्हणजे दीज लाईन्स आर अवेलेबल इन दॅट आयसी, बट दे आर नॉट कनेक्टेड टू दिस OR गेट. ओके. फक्त ह्या 3च लाईन्स कनेक्टेड आहेत आणि त्याच्यामुळे आपल्याला आउटपुट मिळणार आहे की आपलं जे फंक्शन आहे त्याप्रमाणे. इथे पण ज्याप्रमाणे आपलं फंक्शन आहे त्याच्याप्रमाणेच कनेक्शन होतील आणि मग आउटपुट मिळणार. सो दो द आयसी विल हॅव एन नंबर ऑफ अँड गेट्स अँड OR गेट्स, बट डिपेंडिंग ऑन आवर रिक्वायरमेंट वी कॅन प्रोग्राम इट or configure it. So this is a programmable read-only memory. Okay. So once you do these connections, this is a read-only memory. Okay. But actually ROM, that means read only memory. So that means once you program it or you configure it, you cannot change it. But here, these connections that you can program, so that or get connections that you can program. Okay. Now another type of structure, that is a programmable array logic. Okay. So here, and array that is programmable, while or array that is a fixed. So whatever connections you want to change or program, that you can do at a in input, that is a and array. Okay, but whatever product terms that you are getting from this and array, that are fixed, and depending on that there will, as or array that is a fixed, so you cannot change or configure at this or array, and you are getting the output of this or array, that is m number of outputs that you will get if you are having n inputs. So you need to program depending on your requirement. So let us take one example of this programmable array logic. Okay. So here we have two Boolean functions. One is the a, that is equal, or Boolean expressions, that is a is equal to xy plus x z bar, and another function that is a b is equal to xy bar plus y z bar. Okay. Now here, in a programmable array logic, as we have and array that is a programmable. So that means connections which are available at the AND gates, that is programmable. But whatever connections that are available at the OR array, that are fixed. Okay. So here you can see that as we have three input, uh, suppose we have three inputs, that is the x, y and z. So each one will be having a logic, that is a 0 or 1. So x may be having a 0 or 1. So depending on that, here we will have the inputs, that is a x or x bar. Okay. So if these inputs that are connected to the AND gate through this connection. Okay. So here where there is a cross, that shows that it is connected to this AND gate. So you can see that first AND gate is connected with a terms, that is a x and y. Okay. So this will give us the output, this first AND gate that will give us output x and y, and this second out AND gate that will give us x and z bar, because it is connected. So this you can program. हे connections आहेत, हे तुम्ही प्रोग्राम करू शकता. इथले जे काही फ्युजेस आहेत ते ब्लो ऑफ करून तुम्ही त्यातले कनेक्शन्स रिमूव्ह करू शकता, आणि बाकी जेवढे हवेत तेवढेच कनेक्शन्स तुम्ही इथे इंटॅक्ट ठेवू शकता. ओके. Then this third AND gate, it has the connection that is a x y bar, and fourth will have y z bar. Okay. So in that way you can do the connections, and then for a to be available at the output of this OR gate, there should be a fixed connection between this lines. Okay. So this a xy and xz bar, that will be connected to OR gate. Okay. So these connections that are fixed. So once you connect it, it will be remain intact. You cannot change it. But here you can program it, and then if you want to change this function, that you can do it using a different program. Okay. Then here this will be again a fixed connections which will be available at this OR gate. So this is about the programmable array logic. So remember that in a programmable array logic, AND array is a programmable, while OR array that is a fixed. Okay. And now let us discuss about third type, that is a programmable logic array. So in that, AND array that is programmable, as well as OR array that is also programmable. So if we have a number of inputs, so depending on the programming, we can get m number of outputs here. Okay. So here we can program AND array. So depending on the requirements or the product terms that we want, so we can have a programmable AND array, and then to get the particular sum, we can program this OR array also. So this is a both AND as well as OR array, that can be programmed in a programmable logic array. So now let us have the example of this programmable logic array. Okay. So here you can say in this diagram that this and array connection that is programmable, and also here also this is a programmable. Okay. So we can implement these two function boolean expressions using this programmable logic array. So a, that is a xy plus xz bar, and b, that is a xy bar plus yz plus xz bar. Okay. So depending on our functions, we can connect those inputs to this AND gate. Okay. So here in this case, for the first AND gate, you can connect x and y. So this can be programmed as again. For this AND gate, you can have x, z bar and so on. Okay. So म्हणजे ज्याप्रमाणे तुमच्या टर्म्स असतील त्याप्रमाणे तुम्ही AND गेटचे कनेक्शन्स करू शकता. ऍक्च्युली एवढ्या तुमच्याकडे अवेलेबल इनपुट्स आहेत, म्हणजे एक्स एक्स बार, वाय वाय बार अँड झेड झेड बार. ओके. आणि त्याच्याप्रमाणे तुमच्याकडे जे काही कनेक्शन्स असतील, तुमच्या ज्या प्रोडक्ट टर्म्स असतील त्याप्रमाणे तुम्ही इथे कनेक्शन्स करू शकता. आणि त्याच्यानंतर हे जे काही आउटपुट आलेलं आहे या सगळ्या प्रोडक्ट टर्म्सचं, तो तुम्हाला ज्याची सम हवी आहे तिथेच फक्त तुम्ही कनेक्शन्स करू शकता. ओके. सो दॅट ऑल्सो यू कॅन प्रोग्राम, अँड डिपेंडिंग ऑन दॅट यू कॅन गेट available output which is required or which you want to function. Okay. So depending on that you can get the connections. So this is about the programmable logic array. Now here all these are the simple programmable logic devices. Okay. So there are only near about 100 gates that are available in that IC, and these are just a simple connections. For small circuitry you can use this programmable logic devices. Okay. Now as fixed logic devices that are used for the general applications. Okay. So that means general circuitry that are required in most of the circuits that you can have with a fixed logic devices. But whenever you want a particular IC which for particular application only, and where you are using general purpose or general fixed logic devices with certain another component, so in that case you can go for the programmable logic devices. Now let us move forward and then discuss about CPLDs, that is a complex programmable logic devices. Now this is an advanced version of a programmable logic, simple programmable logic device. Okay. So a complex programmable logic device, it is a logic device with completely programmable and or arrays. Okay. So similar to programmable logic devices, it will also have AND array as well as OR array. And with the same, there is a macro cells that are available in a CPLD. Okay. So in this diagram, you can see that there are number of PLDs that are available with certain global interconnection matrix. Okay. So and then there are IO pins that are available for this CPLD. Okay. So this CPLD that contains a bunch of PLD blocks whose input and outputs are connected together by a global interconnection matrix. So CPLD has two levels of programmability. Okay. So each PLD block can be programmed, and that means here as this we have in this diagram, we have 4 PLDs. So all these PLDs that can be programmed. So that is the one level of programmability. Okay. And at the same time, you can program the connections between this interconnection between these PLDs. Okay. That also you can program through this global interconnection matrix. म्हणजेच तुम्ही तुमचे जे काही PLD चे कनेक्शन्स आहेत ते पण प्रोग्राम करू शकता. तिथे तुम्हाला ज्याप्रमाणे फंक्शनॅलिटी अवेलेबल हवी आहे त्याच्याप्रमाणे तुम्ही तिथे चेंजेस करू शकता. आणि त्याच्यानंतर हे जे काही वेगळे वेगळे PLDs आहेत ते एकमेकांशी इंटरकनेक्ट करताना पण प्रोग्रामिंग करू शकता तिथे. आणि त्याच्याप्रमाणे तुमचे कनेक्शन चेंज करू शकता. म्हणजेच तुम्हाला कुठलंही सर्किट जर हवं असेल तर ते तुम्ही या सीपीएलडी थ्रू करू शकता, कारण याच्यामध्ये नंबर ऑफ सीपीएलडी पीएलडीज अवेलेबल आहेत. ओके, आणि मग त्याच्यामध्ये तुम्ही तुमचे कनेक्शन चेंज करू शकता. सो दिस इज अ CPLD, that is a complex programmable logic device. Okay, and then the another type of logic array that we can programmable logic devices that we can have, that is a FPGA. That is the full form of this FPGA is a field programmable gate array. Okay, so it is a more than 10,000 or more than million gates that are available in a field programmable gate array, that is a FPGA, which are available with a programmable interconnection. So here there are different logic blocks that are available in this FPGA, and then you can program all these blocks and you can design any circuitry. So programmable interconnections that are available for users or designers to perform given functions easily. Okay. A typical model that is shown over here in this diagram, and you can see that there are IO blocks which are designed and numbered according to function. For each module of logic level composition, there are CLBs, that is a configurable logic blocks. So here there are configurable logic blocks that are available, and all these IO blocks. So here input and output blocks that you can configure depending on your program, and then you can easily function or perform any function on this FPGA. Okay, so this is a field programmable gate array. And then another type of a programmable logic device, that is an application specific integrated circuit. Okay, so as the name suggests, you whatever is your intention, depending on that you can have a integrated circuit. Okay, so whatever is your application, so for that you can have or customize a integrated circuit. So an application specific integrated circuit, which is called as a ASIC, is an integrated circuit customized for particular use rather than intended for general purpose use. Okay, so I'm giving a stress on this word, that is customized for particular use. Okay, so this is a particular intended for particular application only. Okay, म्हणजे मला जर एखाद्या फोन साठीची चिप डिझाईन करायची आहे, then I will go for ASIC design. Okay, because whatever is this IC that will be solely work for to run cell phone. Okay, so that is a one application. or मला कुठलंही दुसरं ऍप्लिकेशन हवंय, तर त्या माझ्या ऍप्लिकेशन प्रमाणे मला जसं हवंय त्याच्याप्रमाणे मी डिझाईन करणार, then I can call that IC as a ASIC specific or application specific integrated circuit. Okay, so intermediate between ASIC and industry standard integrated circuits like 7400 or 4000 series. They are application specific standard products. Okay, so in this feature size that may shrunk and design tools that are improved over the years, and therefore the complexity of that ICs that has been maximized. Okay, and with the over the years, ASIC has grown from 5,000 gates in a particular IC with 100 million gates in that IC. Okay, so now you can see that. तर तुम्ही जर बघितलं तर तुमच्या मोबाईल मधला आयसी जो काही त्याचा प्रोसेसर आहे त्याच्यामध्ये मिलियन्स ऑफ गेट्स अवेलेबल आहेत, कारण तुम्ही एकच मोबाईल वेगवेगळ्या ऍप्लिकेशन साठी वापरताय. तुम्ही तोच मोबाईल कॅमेरासाठी वापरताय, तुम्ही तो मोबाईल टेक्स्ट मेसेज सेंड करण्यासाठी वापरताय, तो कॉलिंग साठी वापरताय, गेम प्ले करण्यासाठी वापरताय, वेब ब्राउज करण्यासाठी वापरताय. म्हणजे एवढ्या सगळ्या ऍप्लिकेशन साठी तुम्ही एकच मोबाईल वापरताय. आणि ते सगळं फंक्शन करण्यासाठी त्याच्यामध्ये नंबर ऑफ गेट्स म्हणजे मिलियन्स ऑफ गेट्स अवेलेबल आहेत. आणि हे सगळं कसं आपण पॉसिबल करतो की त्याची काही माझी ऍप्लिकेशन स्पेसिफिक आयसी आहे ती मी प्रोग्राम करते डिपेंडिंग ऑन माय रिक्वायरमेंट. सो दॅट इज अ ऍप्लिकेशन स्पेसिफिक आयसी. And then these modern ASICs that often include entire 32-bit processors, then memory blocks including ROM, RAM, EEPROM, flash, and other large building blocks. Okay, so whenever all these blocks that are available in a single IC, then we call that IC as a SoC, that is a system on a chip. Okay, so that means whole system is available in a single chip. Then we call that IC as a system on chip. Okay, so the designers of digital ASICs that use a hardware description language, that is the HDL, such as Verilog or VHDL, to describe the functionality of ASIC. So to describe how to perform that IC, we need to know about particular HDLs. That means if you know about Verilog or VHDL, then you can easily program these uh, ICs, and then you can make that IC to perform depending on your स्पेसिफिकेशन्स. ओके, तुमचे जे काही स्पेसिफिकेशन्स असतील त्याच्याप्रमाणे तुम्ही त्याला वर्क करायला लावू शकता. ओके, so that is about the ASIC. So these are the different types of programmable logic devices. So our main interest is in the now CPLDs and FPGAs. Okay, so now if we differentiate between PLDs and ASICs, okay, so ASICs, that is application specific integrated circuit. So here, as they are having number of gates as well as number of um, functions it can perform, that is why it has a longer design cycle. Okay, but it has the faster performance. Okay, so whenever you are, as it is going to work for a particular application only, so specific application साठी आपण हे डिझाईन करतो, so त्याचा परफॉर्मन्स हा फास्टर आहे. And if we are going to produce these ASICs in a large value, so it has a lower cost. But if you are going for a single IC only, then it may cost a big higher. But तुम्ही जर तो मास प्रोडक्शन करणार असाल तर त्याच्यामध्ये मग तुमची कॉस्ट ही लो होते. म्हणजे कुठल्याही गोष्टीचं जेव्हा तुम्ही मास प्रोडक्शन करता तेव्हा ऑटोमॅटिकली त्याची कॉस्ट कमी कमी होत जाते. पण ज्यावेळेस तुम्ही एका पर्टिक्युलर फक्त एकाच ऍप्लिकेशन साठी आणि एकच सिंगल चिप करणार असाल तर मात्र याची कॉस्ट खूप जास्ती होते. ओके, सो लोअर कॉस्ट इफ प्रोड्युस्ड इन हाय व्हॉल्यूम. सो दॅट इज द about the ASIC. Okay, and if you are going for the programmable logic devices, that is a programmable chip only, so simple version, then it is good for medium or low volume products because it has less number of logic gates, and that is why it is good for low volume products. And if you want a number of chips of a same design, then instead of going for PLDs, you can go for ASIC or hard copy of that. Okay, म्हणजे तुम्ही प्रोग्रामेबल डिव्हाइस यूज करण्यापेक्षा जे परत परत तुम्ही प्रोग्राम करू शकता त्याच्यापेक्षा तुम्ही स्पेसिफिक आयसी साठी जाणं जास्त योग्य होतं जेव्हा तुम्हाला मास नंबर ऑफ प्रोडक्शन करायचं. ओके, सो हियर यू कॅन गो फॉर ASIC or hard copy of any IC if you want to manufacture more than 10,000 bits. Okay, so now coming to the actual our discussion. Okay, so whatever are the different CPLDs and FPGA that are available in the market. So we have Altera Flex structure FPGA, that is a Flex 8K and 10K series. Then we have Altera Max structure CPLDs, Max 5000, Max 7000, Max 9000 series. Then Xilinx CPLD XE 7000 series, then XE 9500 family. So these are available. And then in the Xilinx FPGA family, XE 2000 series, then XE 3000 series, XE 4000 series. XC5000 series that are available. Okay, so this is some of the list of CPLDs and FPGA that are available in the market. Okay, so there are another manufacturers also. They are also having their different CPLDs, but these are the some of list, okay, of these CPLDs and FPGA. Okay. So now, uh, in this lecture, we are going to have the discussion about these only. Okay. Now, if you have any doubt about this, you may ask. Okay. In the next lecture, we are going to discuss with CPLDs. Now, in a more detail, we are going to discuss about Alteraflex uh, model, and we are going to uh, see about the Xylem CPLD also. Okay, so that we are going to discuss in the next lecture. But right now, if you have any doubt about these PLDs, then you may ask. We have still some more time, so you may ask. कुणाला काही डाऊट आहे का?